you have any questions, also I would like to tell you you can write in the chat area. So I will collect all questions, and at the end of the presentation, we will ask one by one from Dr. BenthoTorch. So yeah, enjoy, and I hope that you will have a very good, fruitful webinar. Dr. BenthoTorch, stage on you.
Yeah, you saw this comment probably that we have one visitor who could not see the video and no sound. So
I will check it.
You will check it, yeah. So it's on me. Good morning, or wherever you are. Good afternoon. I'm very happy to start this year with our first webinar on Phytobenthos measurement, and I've named it, it's a simple application for a complex problem. Phytobenthos, yeah, that is something which I would like to explain a little bit more, but first have a look on the agenda which I have. This is what I want to explain. First, what is Phytobenthos? And in this case, also the importance of this benthic algae, especially something which we have to deal with much more in the future, is the role of cyanobacteria in the benthic communities. And of course, it's now very important to see how we can assess the benthic algae, what kind of method, techniques we have. And I want to go a little bit more into the details of the measurements. Of course, we have an instrument that was developed by BBE. This is the BenthoTorch instrument for measurement of these benthic algae, especially the microbenthoalgae. And of course, at the end, we would like to invite you for any question or open discussion. You know, we are quite open for this. This is the policy of our company, that we want to share with you all the experience and the idea that you have. So let's start up with the benthic algae. Let's start a little bit earlier with the benthic zone, where we have all these organisms that are living close and attached to the bottom of any, let's say, ocean, lake, stream, river, wherever it is, mainly in shallow waters, and they live very close to the sediment, like rock or other type of particle substrates. And these bottom dwellers, or you can call them inhabitants, that make photosynthesis, they are called phytobenthos. And we have two types of phytobenthos inside of these waters. These are the, let's say, the macroalgae, which are settled on the bottom and rather large. And we have also the microscopic small algae, which we call the microphytobenthos. It is similar that what we see also with the phytoplankton, but phytoplankton is freely suspended in the water, while microphytobenthos, these are algae which are very close to the bottom. And you see a picture downstairs here, the formidium. We will talk a little bit later of this. This is something which we call the cyanobacteria, and these have an important role in this microphytobenthos. So let's go to the surroundings of the microphytobenthos. This is a picture from US EPA, or USGS Gov, and you see there is an interference between the different areas. We have here the water, the phytoplankton, which I mentioned before, with the algae, with the zooplankton, and we have here also the microphytobenthos. This is the zone which is very close to the bottom, also the sediment. And we have, of course, an interference between them all. This is part of the exchange of different nutrients, let's say phosphate, nitrate, and carbon. But we have also the the dissolved oxygen, which is also produced by the phytoplankton and by the Phytobenthos. So we see this is not an isolated system. It depends one on another, and there is an interchange between the different zones. So we cannot see them only alone. We have to look for both of them. And if you are a little bit familiar with our company, you know that we have developed instruments that can easily measure the amount of phytoplankton which is free in the water column. But now we have to go to the details of this phytoplankton in the benthic zone. And this is something which is very special here. We have so-called biofilms. And biofilms, that is a complex community of organisms that you can see at the bottom. And here we have a mixture in a complex way with bacteria, with microalgae, which means mainly diatoms. We have the cyanobacteria, which I mentioned. If you're not that familiar with them, they are also called the blue-green algae, and they belong a little bit more to the group of bacteria. Then we have, of course, the fungi and some other organisms, the protozoa. And they all together, they form this biofilm. And the sketch here, you see down in this picture, they are mixed and they cooperate and they digest and they produce and they make a lot of different things inside of this. So which means that we have here a lot of biomass, which is localized at the bottom of the lake or river or ocean. But clearly to say, they are not that far away from the surface of the water, because if you look, for example, the microalgae or the blue-green algae, the cyanobacteria, they need the sunlight to make photosynthesis. Now the question is quite clear why we should care about benthic algae. Of course, it's important to know about the water quality, and you know, algae and also other organisms like zoo or plankton or phytoplankton, they have to do something with the water quality. And of course with the ecology, because the mixture of the different organisms, they depend on the water quality. So it's absolutely necessary to have information about this area. And if you think that these is in let's say more shallow areas, it's important to see that it's very important to reflect the primary production of this. They make a lot of biomass, and of course they make a lot of oxygen, which is also used by all the consumers like humans also. So in European, we had a water framework directive which defines the ecological status in rivers and lakes. And they clearly state that it's important to see the different elements which are important. It is, for example, the phytoplankton, it is also the Phytobenthos, but together with the other invertebrate fauna and also with the fish. And here in a special case, you can see that some of them, they can produce harmful substances. And these are, for example, the cyanobacteria or the blue-green algae. They are responsible not only for biotoxins, but they are also responsible for taste and odor. And especially in these areas where they want to prepare drinking water from this raw water, it's important to prevent the intake of such biotoxins. And this is something which especially cyanobacteria do in fresh water, but sometimes also in seawater, that they prepare these biotoxins, and I won't come back to this. And due to the nutrient situation, we have also another effect which is important. In this state, we have sometimes a very high concentration of biomass, which can lead to fouling. And here also the cyanobacteria play an essential role in this process. And when we look here for this picture, that is especially taken from Japan, where they have something like fish farming, or let's say it's a cult to fish here, special fish, the ayu, we can see here the complex cooperation. This fish is fed from Microphytobenthos, and of course this fish can only live in such a good way if the situation or the water quality is in good health. And this is a sport here in Japan where they can find if the quality of the Phytobenthos is in good, then of course the health of the fish is also good. And it is said, I do not know, that the taste and the fish is especially good, not only for health, but smells good. People like it very much, and it should be a little bit like salmon. I never tried it. So let's have a look what we see from the advantage of this benthic algae monitoring. Well, this algae monitoring, as I explained, are a complex mixture of different organisms. And if we have something like pollutants or changes in the environment, we can see this also in the Microphytobenthos, because they have very short reduction times, so means they react very fast on these changes. Let's think that we have a pollutant inside of the water. You can immediately, or in a very short time, that there is a change in these organisms. And we have standardized methods for this. For example, we are able to collect samples and make a cell counting. It is a traditional way. We have other ways, and I want to go more in detail here with this presentation. That is the measurement of chlorophyll A. It can be done by, let's say, extraction is also the classical way, or we can use fluorometry, which I want to show you a little bit later here. We have also the so-called photosynthetic activity. That is a measurement of the photosynthesis itself. It's not the biomass, but it says how much biomass is produced. We have different methods for this. I can answer the question if you are more interested in details of this. And of course, we have the possibility to make the analysis of the different metabolites, some of them which are produced of them, of the Microphytobenthos, but also, let's say, some of the biotoxins. But this is, of course, laboratory analysis and cannot be done at site. But this is also something which I have to mention here. Some of them, of these methods, can be done in situ, and that means at site where we take the samples. Other samples have to be transported to the laboratory and analyzed later on. So let's come back to the cyanobacteria. So in some cases, when the nutrient situation is rather good, means that they have nitrogen and phosphor enough to reproduce themselves, then they will be able to produce also a higher amount of biotoxins. We really do not know why they produce these biotoxins. Maybe they can protect themselves against feeding, but nevertheless, these biotoxins are harmful to many other organisms, especially to livestock, but also very well known to dogs and cats, but also for swimming and for human beings. That means if they ingest these toxins, they can become ill. So another effect is if they proliferate, they can also displace other algae, they overgrow them, and this can lead to the already explained fouling. And with this, they also consume the oxygen in the water, so it may become anaerobe, which is also harmful for the other organisms inside of the biofilm. And for the water production, drinking water production, they release taste and odor components, which you can see. Oh, you can smell it if you come, let's say, to a little pond with a high amount of cyanobacteria, you can easily see or can feel the smell of these compounds. So they are not acceptable, especially in drinking water, and we have to avoid this. On the right side, you see a typical presentator of this filament of nostoc. It is the same family I showed you in the initial slide for the Formidium. Also, cyanobacteria produce such taste and odor compounds. Up to now, it is not that much shown in the literature how to deal with the toxins. But here I've took paper from, I think it was from 2020, about benthic cyanobacteria and where they are found in the world. And this is a report about the global distribution of the different types of cyanobacteria which make those harmful compounds, those biotoxins. So we have here two groups of them. This is the anatoxin and the zaxitoxins. They act as neurotoxins. So, for example, they can act on the ionic channels inside of the organism, and they react very fast. So it is, let's say, what is called a very fast death factor, an anatoxin A. This is something which we can see, for example, which causes the death of dogs in a very short time. We have other organisms that make this selenospermoxins, which is well reported in Australia, but we have it also here in freshwaters in Germany. They produce selenospermopsin. That is a toxin from Raciborski, which acts on liver and on kidney, for example. And the Australian waterworks, they try to determine this type of cyanobacteria. And then a very common type is the microcystin or the nodularines. These are inhibitors of phosphatase enzymes. They do not react in a very short time, but they are very well known as hepatotoxins, so that they can act after, let's say, a short term or prolonged time, and can lead to deaths. And we had some deaths with some waters with the microcystin about more than 20 years ago in a hospital. So it is very important to visualize them. Usually this is done in fresh water, in the pelagic water, that means in the free water as phytoplankton, but it is not that typical that the benthic algae are investigated. Unfortunately, these analyses for this biotoxin has to take place in the laboratory, and we use sophisticated instruments like HPLC, that means chromatography, liquid chromatography, together with MC, and we can see and we can see that it takes time to bring this to laboratory. That means if you want to perform this wanted analysis, it's more complex, costs time, and there's nothing that can be done at site. But what can be done at site is to determine the algae that produce these biotoxins. And we have here different types of determinations. We have here someone who collects the samples. This is a phycologist. The name is Frank Acker. He sampled the algae from the surface and brought them to the laboratory. So what he's done, he scraped these biofilms from the surface and put it in a, I don't know here, put it in a bag. And then in the laboratory, this was extracted with organic solvent and measured spectrophometrically for the amount of chlorophyll A. Another method is also to resuspend these biofilm and fixate it with Lugolce solution, which means that we can determine under the microscope which kind of algae you can find inside of it. Of course, it takes a lot of time, and during transport something can happen, and therefore the BBE company did something where we know best about use fluorescence measurement of algae, and here we developed an instrument that can determine in situ measurement of the chlorophyll A. This is the instrument here down, that is the BenthoTorch. So you can see that it is put inside of the water on the surface of here a rock and determined as fluorescence. I will tell you how it works. We have here the BenthoTorch, and the BenthoTorch has light sources which illuminate the photosystem, and the photosystems are several pigments which collect the light and bring it to the center where the photosynthesis takes place. But part of this light is also transferred to fluorescence, and you can see here that the fluorescence is emitted, and the fluorescence is measured, or the intensity is measured here, and is indicator for the amount of chlorophyll A which is inside of the algae cell. So we use this low light excitation where the fluorescence is proportional to the amount of chlorophyll A. And when you measure this, then we have the ability to transfer it electronically and determine the amount of algae which are inside of this biofilm. Here I show you the screen of the instrument itself, which shows some diatoms per area, and it also can show other types, which I show in the next slide. We have the 3 dominating algae classes, which can be measured by the BenthoTorch. These are the diatoms, the brown algae types, the green algae, and the other type of Microphytobenthos, the cyanobacteria. And what we have here is the so-called excitation spectra. We have different light sources, as you could see in the picture before, and we excite the photosystems with this light at different light sources. And here is the measured fluorescence we got from this excitation. And you can see that we have different spectra, so we can use the different light sources to calculate the amount of cyanobacteria and microalgae inside of this biofilm. So that is the principle that stands behind it, and we are able to distinguish roughly these classes. So what we did a lot of measurements with this, and this means that we tried to let the Microphytobenthos grow on different materials. And we have here stones, plastic discs, transparent foil, glasses, tiles, everything which we did. And we compared this to the traditional method. The traditional method, which means, again, is a spectrophotometry chlorophyll A. So that means that we have to add organic solvent and extract the chlorophyll A in this organic solvent and measure chlorophyll A in a spectrophotometer. When you look here, the comparison of the BenthoTorch against the spectrophotometrical approach, then you can see that is quite fair linear, and we had a, let's say, fair correlation of 0.79 or 0.80, and the slope is roundabout 1. That means that we have a lot of different measurements where you can see that it works quite fair. There are some reasons why it might not be identical. And of course, we have to deal that these methods are quite different. But I mentioned to you that also the different way of taking the samples, transport them, subject them to extraction, and so on, that can also change something in the comparison and make it not that clear that we have such a good correlation. And this is, of course, also reported in the literature. Sometimes you see that it works quite fair, and sometimes it does not work quite good. Sometimes we can find an explanation, but not very often. But I can show you some reasons also for that. About the measurement itself. Measurement is quite easy. I do not want to go too much into the details. We have here at the bottom the substrate, which may be rock or another sediment. And we have here above the biofilm, and we put the BenthoTorch on top of this biofilm. And then we have to start up. We have here soft keys, which can start this instrument, and then it works automatically. Everything is automatically. So that means inside of the instrument, we have all this measurement and also the calculation of the amount. There is a software included that use these fingerprints of the algae spectra to determine the amount of Microphytobenthos inside of it. So the measurement easily takes place, and you measure, let's say, here at the surface. You see that here we have a red cover, but later nowadays it is a black cover, which shields the measurement against ambient light from the sun, for example. It's important to know that we have to take care for this. So that is very easily be done, and then after a short time, let's say after half a minute, you can read the results directly on the integrated display. An experiment which we performed with different materials, natural materials, and we used here stones, different stones for 30 days, and measured them before and after growth of algae in a lake very close to our company. And you can see here the results. In the beginning, in the before experiment, we see very low amount. This is a microgram chlorophyll per square centimeter. I took only here as an example one stone. On site, we measured different places on this stone, and you see that we have also some differences. Yeah, that means that is not evenly distributed on this stone, but you see that it is quite different. And so you can imagine it really depends where you take the sample when you want to compare to scraping. So you see that it is important to make different measurements, not only take one measurement to get a reference. When we bring this to the laboratory, yeah, and scrape it, distribute it, and measure it also in our fluorometers, we see that we have a quite different place here. So it's also, it reflects that it's not that easy, that it's always the same. Yeah, you know, that is now resuspended matter, but what you can see, it is not the same. That means we need a lot of samples to make a comparable, to get a comparable result. And after scratching, yeah, we see on the stones still, may see in some caves, that they are algae shown with a BenthoTorch, which reflect that we could not scrape everything from the surface. That means we have here an example where we can see that scraping cannot extract all this algae and show that is really good representing. And therefore we think it's important to make a lot of samples here, for example, with a BenthoTorch or with a fluorometric device to determine the, let's say, mean value of biofilm Microphytobenthos that we have on the sample. So that should clearly show that it has some advantages to take more samples and do a fluorometric approach to see more the difference between the different situations. You see here some examples, and many people use artificial substrates, for example, tiles here, and they measure it here outside of the river and to determine this. This is some of the examples. It is most people use these tiles, which makes it much easier to determine. In these tiles, you do not have these caves, for example, and it makes it easier to get real results which are representative for the ecological status. Other example, for example, is here on a measurement on the roof of an airport. They want to see the growth of algae on this roof. And of course, we can measure on every surface. We can measure surface like on windows. We can measure surfaces on walls and so on. For example, the buildings also are affected by cyanobacteria. So there are many different applications to use the BenthoTorch. Yes, these are the advantages and the benefits, of course, but we have also some limitations, and I want to go a little bit into the details. And this is why I make also this this picture here. Let's assume that is a graph of biofilm surface. Yeah, and the surface is here, and these are the deeper layers. Let's come back to the different colors. What we cannot measure exactly is some algae or some cyanobacteria which contain the phycoerythrin. We measure mainly the phycocyanin, which is the most prominent pigment besides chlorophyll A inside of the cyanobacteria. Our sensor is not able to make a good measurements. It is underestimated. So that means that we have some of the Microphytobenthos which are related to the cyanobacteria with phycoerythrin. They are not well represented. The same stands also for the rhodophytes, red algae. We have also higher amounts of phycoerythrin which cannot be seen in that high amount. That means if we have some of these algae and Microphytobenthos red algae here in our area are really rare, so we did not realize them. Mainly, we saw them mostly as macrophytes. The other thing which we have to deal with is the layer thickness, or the mats what we have. Let's assume that we have here the thickness. We have the light that should excite the photosynthetic apparatus. And if we are here at the surface, it works quite well. We can excite the green algae or here the blue-green algae, but if the layers are thick, then it cannot excite it. And this means that for thicker mats, it's difficult to determine. We have a first assumption, which means that the difference of, or let's say the layer deep depth of the benthic zone, which we can measure, is, let's say, around about 100 micrometers. The other thing, what we see also, that we have decay products. This is in the deeper areas where we have the conversion from chlorophyll A to phaeophytin. That is also fluorophore, but much less be excited. So if you scrape them, of course, you can get this in the sample and will find it also in your sample. With this BenthoTorch, we see only little effect of this, but if you scrape it, and especially if you have a higher density of biofilms, then it will come inside of your sample and can make effects which can also affect the results of the comparison. Another thing is that we really need pre-illumination. If they are pre-excited by the sunlight, the fluorescent signal that we get from the microalgae is not in direct relation to the amount of biomass or chlorophyll A. It's not linear, but if the light excitation is low and it's not pre-illuminated, then we get a good result from the chlorophyll A estimation. Another thing is soft sediments. Soft sediments means if we measure on sand. In the beginning, we started in tidal zone. It's very difficult not to disturb this. That makes it really difficult. We have to come very low speed to the surface so that we do not disturb this. The other thing, of course, is I mentioned already before, is the method of comparability. Then we have different kinds of methods that we can be used, and it's clearly to discuss how we can compare this. We have, for example, the intake of C14 into the biomass and measure this. We have the measurement of wet material. So then we can not easily compare all these methods and make it clear. Another thing which is very difficult is that we have to deal with the growth on other organic substrates like macroalgae and plants. It does not work. So we had a literature where it was shown that it does not work very well on moss, and clearly it's not made for measurement on moss. It's made for measurement of Microbenthos on sediments like rock, sand, or other substrates. And another thing, last, is the handling itself. You can take it underwater, of course, but you cannot take it so deep that you can start, because the soft keys, they only react if you are outside of the water. So you cannot start as a diver with this instrument. You have to start this instrument, and then you can go into the water and determine underwater this measurement. And you can use a continuous mode so that you can get this information, but mainly it is done to make measurements close to the surface. These are some of the limitation uncertainties which I like to mention. And I would like to cite here literature that mentioned the BenthoTorch. They say that can provide semi-quantitative data on chlorophyll in situ measurements of chlorophyll A and the taxonomic groups. I hope I could explain this quite clearly, and that can be placed underwater also on benthic mats. And here we have also this kind Microalgae, which is closely related to Formidium and also cyanobacteria, and they could show that they can report it in good correlation of biovolumes when they are rather small. But of course, this relationship weakened when the mats increased. And it is probably due to the growth of the mats, where you cannot excite the lower layers. And of course, what I also already mentioned, that, that they cannot measure the phycocyanin containing cyanobacteria inside of the meth. So at the end, I can summarize the benefits, of course, that we can do a real-time measurement with this BenthoTorch algae concentration at the surface. It's quite easy to get more information about the ecological status, because we can assess a lot of different places, get much more information compared to the classical ways to scrape and extract this with laboratory samples. That makes it also more cost effective. The instrument does not need any chemicals, for example, and does not need any other instrument to determine this amount. And you can measure at site in a very short time. So it helps to make this field measurements. Yeah, and that's, I think, compared to microscopic analysis, of course, it is not that clear comparable, because the level of analysis is much better for microscopic analysis, but to get a rough information about the different algae classes, I think it is clear, fair way to determine the ecological status and the families of algae and cyanobacteria inside of a sample. So the conclusion I come to is that the BenthoTorch is a non-invasive method, so it does not disturb anything of the algae cells. And to say it's carefully, it's estimating the chlorophyll A content. We can say we try to measure it effectively on all surfaces that are used. I told you a little bit about the limitations. And we are here able to collect a high number of data in a very short time and allow statistical relevant statements of the periphyton population. I think benthic population is a better word for that. Yeah, thank you very much for this listening to my intention. I want to close this with a picture which shows here the tidal zones of northern Germany. We are living here not very far away on the right side of it. The story starts here with Isle of Helgoland, where we had a very close cooperation with the Alfred Wegener Institute. I have to acknowledge this cooperation. They helped us very much to develop this method and did a lot of measurements also here in the tidal zones, which are still here very interesting part, very important also for our nature. And I want to close with this and thank you very much for your attention, and hopefully you have some questions and we try to answer this. Thank you very much.
I have received some questions, but also if anyone wants to ask his question or her question, you can unmute your microphone and ask directly, or I can ask from Dr. Detlef. Anyone? Do you have any question? Do you want to ask a question?
Don't hesitate. We are quite open.
Oh, I see Mr. Duke also. Anyone, but before you ask, I received one question. Question is that how large is the scan area, Dr. Detlef?
So the area, yeah.
Yes.
Well, it's rather small. Of course, we have to focus on a certain spot, yeah, and the area is 1 square centimeter, so you are very close in front of the exciting lamps or the LEDs. So that means you put it on a spot where you want to measure in the size of 1 square centimeters. I think that's quite good because it's quite fair also related to the calculation afterwards. That means if you have a stone, we like the stone number 9, which I showed, it's quite good to make, let's say, 10 measurements of this. Yeah, I showed only 4 of them in this picture, and but 10 measurements on a stone is quite good to give a representative overview over this. Then you have, let's say, 10 square centimeters measured in total.
There is actually, I think it's related to this question that Matej asked from Czech Republic, that in the photos we can see that BenthoTorch is used on the shore on rocks. Does it interesting feature BenthoTorch can be submerged up to 10 meters underwater?
Well, the BenthoTorch is, let's say, in the body of the algae torch. Yeah, that means that we have housing which is dense for, let's say, for 10 meters. Yeah, that 10 meters is, let's say, what we can guarantee. Yeah, we use this also for other depths, but we say clearly you should not do that. 10 meters is that what we can expect. That depends also on the plug. Yeah, then the plug is not that water resistance, you know, that the pressure exceeds when you go more deeper. And therefore we have a plug that is needed to connect the BenthoTorch with the cable when you want to read the results. And this plug is water resistant, let's just say, to a depth of 10 meters. So therefore, we do not recommend this, and it does not really make so much sense, because you know that we are mostly working in shallow waters where the microbiota is exposed to sunlight, and in many cases the depth of the sediment is not deeper than 10 meters. Of course, we have some outstanding results, or I saw in the literature that a rhodophyte is able to settle on the bottom at 200 meters, where they get only 1/10,000th of the light from the sunlight, and it still can grow. But this is under not normal situation. The one we have is that we could cover most situations with a BenthoTorch in very shallow waters. So it means that we put it inside of a water. You know, the size is, let's say, something like this. Many people, and you can see it also in a picture, they apply it in areas where the water is not more than 1 meter depth.
I see. Thank you very much. Also related to this, I'm sorry, Gianmarco, I don't know why you cannot unmute it. Perhaps anybody. No, it's it's working. Okay, good.
Oh, hello, Babak. So
hello.
I have just a bit technical problem.
Okay, let's go on. If you have any question, you ask a question. Maybe you can ask yourself.
No, I just only to ask about the maintenance and calibration of the instrument.
Okay.
Maintenance. Yeah, clear?
Yeah.
And calibration.
Yeah. Sorry. Yeah, maintenance, not that much to be done. I think the most important thing is to keep the optics clear. Yeah, that means that you have to look that you will not find biofilms grown on the lens of this. That it's not that much to have to do. Just use a close like this one to clean it, optical close, yeah, and then everything is done. On the other hand, what maintenance, there's nothing to do with the maintenance itself from your side. It should be done for surfaces, for example, for recalibration, or if you see something which is irregular with your results. We have some possibilities to check this here. For example, you can read out your data, or you can send us your data and ask if there's something irregular with your data. Then, for example, we can check here the brightness of the LEDs. But you can also do this by yourself. We can inform you how to perform this. Usually nothing has to be done until, let's say, for a period of 2 years. Then we recommend, it's not obligatory, to resend the BenthoTorch back to our company. And here we can do the calibration or the recalibration. Shall I tell you something about the recalibration? I think not that recalibration, what is needed. When you have the BenthoTorch inside your institute, then you have in you have some plates inside of it, different plates of different colors, which can be used also for recalibration. And we use these plates. We have holes inside these plates, not that deep, where you can add some algae. And we use these plates to, with our algae from our laboratory, which are reference algae, which are well suited for the BenthoTorch calibration. And we use them and added a very small layer of this algae with a known amount in the hole of this plate, and then we recalibrate with this BenthoTorch the amount of algae classes which we could add as a spectrophotometric fingerprint inside of the algae. So that can be easily done, as we all other fluorometers are also. So we have the information of 3 algae classes inside of the instrument. And what we also see is if there is something change in this spectrophotometric fluorometric pattern. Usually it's not the place, and sometimes there's really no need to make this measurements anymore to see the performance of the instrument. But our recommendation is to do this to be on the stable side every 2 years, send it back to us. This is all that have to be done for the maintenance and services.
Thank you very much. We have 2 questions in the public area. One is from Duan Yeo from Singapore. Duan, would you like to ask your question yourself, or can you unmute your microphone? Duan? Okay. Is it possible to unmute? I don't know what is wrong today. Maybe.
Can you?
We try it once to see how it works.
If it's not, sorry, we cannot hear you.
Wait. I am allowing.
Is it possible to write in the chat, for example?
Yes, he wrote it.
Hi,
The
Babak.
is, yes, hello. Yes, I see.
Hi, Babak. This is Saurabh here.
Hello,
from DM.
Saro. Go on. Yeah, you made it.
Yeah. Yeah.
Okay, please
Yeah.
go
Thank
on.
you. Thank you for allowing me to speak.
Welcome.
Yeah.
You're welcome.
Actually, just we have one questions that we have. There is a large set of data for this. We are collecting for this blue flag accredited beaches. Okay, and for we are means we are included measurements for cyano, green algae, diatoms, and total concentration. But all are beaches mainly, public beaches. These are all the blue flag accredited. Now, question is that we are just lack of clarity on how to best utilize these informations and what should be the specific objectives should we establish for this data and what potential analysis for this action could be undertaken. So this is my actually the question when I just go through the data or means what should be done. So you will be the
So
better
you
person.
mean that is there maybe another way of the question? My understanding from this question is that is there any standards or any guidelines to take care in the concentration, or you mean about how to evaluate data for the future analysis, or I don't know, forecasting or something like this? In what sort?
Yes, exactly. Yes, exactly. I just would like to get some guidance that exactly means what should we do with this means the data. This we have the large set of data means all the data when we have then we have to do something. So if you guide us that what should be done.
That is not that easy to answer because what we can say is that we do not have real thresholds for something like this. We have some clear thresholds for, let's say, phytoplankton. So for phytoplankton, you can say, or there are some guidances which say that you are above a certain threshold for cyanobacteria, or we are above a certain amount of nutrients. Then you can say this is a guidance you should do or take action. For the Microphytobenthos, this really does not exist. That means that we have not have enough knowledge about this. People are not that much aware about this. We only can see, let's say, on a level of quality. Yeah, on a level of quality, that means the occurrence of some of these types of, let's say, cyanobacteria reflects there could be something harmful inside as an indicator, but it is not that clear. The community, as also the, let's say, the scientific community did not care so much about this point you asked for. You're quite right, but we are a company who developed an instrument to make these measurements, and we are not able to give this guidance. So what we need is that something, let's say from the World Health Organization or for an institute for environmental sciences, would like to give out some information what could be expected and what are the consequences of this. What we know only is if we have certain amounts, let's say of this nostoc, of this formedium, or this microcystis, then uh, we can expect that we have some certainty for the presence of biotoxins. That's all we can say at this moment. So it is important to say that we are not able to give a clear guidance or forward to some information which could help, let's say, the organizations to take action. The actions are, let's say, more on that side that someone has to say, how can we prevent much more to the income of nutrients, for example? Yeah, what we can do to avoid the leakage of farmers' water. Yeah, that is something which is important, and it is also important to forward this information to the policy. So it is another basis where we have to act for. But I think that this is information is important to forward. Also the let's say the ecological quality to improve the ecological quality in such waters. And as I see, and I think I mentioned it is before, we have a lot of information. So let's say from ships and from other methods where they measure the phytoplankton in the pelagic waters, but not that in these areas where you find the Phytobenthos.
Yes, Doctor, thank you so much for your clarifications. Just only one thing, as a municipality, we have the different sectors or different jurisdictions to work. Means if this particular instrument, if it does not work in the coast, then we can shift to in the lakes. You understood what I'm saying? Means if this BenthoTorch, if because in this marine ocean system we could see only diatoms and dinoflagellates, but cyanobacteria we find very less. It is there, but cyanobacteria, how much it could pollute the ocean, we have little not that much data we have till now.
Mm-hmm.
So if you suggest us that we could this one we can shift to the lake study, and then we can get some another instrument what already your already I spoke with Mr. Babak earlier, so we can get that one for our beach study. What's your suggestion in this?
I'm not clear that I understood everything right. If I'm right, Babak, you may have
Yeah.
Okay, go on.
looking for other types. Is it correct?
Yeah, actually, I think that we should, one comment I have. Today we talked about benthic algae and BenthoTorch. So as you mentioned, in the tidal area, it is very hard to use BenthoTorch because this soft sediment. Detlef, am I right?
Yeah, yes, that's right. And we have, especially for the other methods which I mentioned to measure this, of course, we tried out, and there were some developments to measure also in these tidal zones. But there is another method which is used mainly here in Northern Europe by this scientific institute. They call it the cryolander. So that means that they used liquid nitrogen to cool down the sediment, and they take the sediment together with the bottom and put and cut it into slices, and look under the microscope what is inside. Our
Now, Yeah, just one thing. In this case, if imagine we were able to sample it and we are able to measure it, but we are not normally we are concentrating on the diatoms and cyanobacteria in a coastal area of Dubai. Normally we are facing with maybe I don't know the benthic algae of red algae, because you mentioned in your presentation that red algae also something that we are not maybe able to measure.
Mhm.
So what will happen in this case? That we take a sample and now we are forecasting that maybe expecting to see this algae types. What will happen in this case?
Well, we have, of course, we are able to determine the brown algae, which is a very
Of
large
course.
group. Yeah, that
Yes.
means that it can consist, let's say, on also of dinoflagellates and diatoms. But as you may know, or my experience is, for example, that the dinoflagellates, they are much more motile. You find them rarely inside of such layers. So therefore,
Yes.
it is not that important to see them, or at the moment, we are not able to distinguish them inside with this instrument. We are working on something like this, but let's say it's another way. For the cyanobacteria, we know that we have them, of course. My experience is that in seawater, maritime waters, the cyanobacteria, which are not that much as in fresh water, but they sometimes have much more of the phycoerythrin. And we can see the phycoerythrin also a little bit with our BenthoTorch, but clearly I have to say it is underestimated. So that we see what is mainly we see this, I call it the blue type of cyanobacteria, which have the pigments phycocyanin beside chlorophyll A inside of it. And partially we can see also this phycocyanin, but I saw some really red type cyanobacteria. This forminium, for example, I showed in one of the first slides, they could become pure red color. Yeah,
Mhm.
and we can see them with a BenthoTorch, but if we compare this amount that we mentioned from chlorophyll A, we measure chlorophyll A to be able to be sure that we measure chlorophyll A, but the effect is not that clear as we have the phycocyanin on chlorophyll A. So that it clearly can say that it will be a little bit less, but here we
It
can
is
say
indicative. It is indicative.
it is an indicator, but it is not quantitative. And so that is why also the literature say it is, let's say, semi-quantitative. Yeah, and of course every method has its limitations, and here we have also the limitation, and we cannot extend it. We have only these 3 channels for the excitation of the pigments, and therefore it is.
Thank you very much. Thank you very much. So I think that we should go to
Thank you.
Mr. Duan. Thank you very much. We talk later maybe about this issue.
Yeah, hi, Delta, yeah, Dovan here. So I saw one of your slides for the you're using a brakes for the sample taking. So I'm
Yes.
wondering how long would you need to soak the brakes in the water before you take out for a measurement so that it's representative the result?
Yeah, also that well, when you have a pre-illumination, for example, from the sun, yeah, then the pigments are already excited, and usually you need a relaxation of the energized status, and this takes some time. Uh, there are different ways how this can relax, and one of the most relaxing things is that you release all energy from the electron transport. This rate goes rather quick, and in my case, for example, when I measure here downstairs with our examples, which I took from the ponds and so on, I use it, let's say, for 2 minutes to be sure that we have relaxed systems. And in the field, sometimes they say you need 20 minutes, but of course you cannot do this in the field. Yeah. it is something which I expect that it could be between 30 seconds and 2 minutes to find almost complete relaxation. I think 90% relaxation should be enough to make a good measurement. But does it mean that when you, after this period, you make this measurement, you find a linear relationship between the fluorescence signal and the chlorophyll A content measured or determined by the BenthoTorch? So this is what I see, or what I know from our experience. Of course, the longer you perform this relaxation or keep it in the dark, the better it is, but practical use says that it's sufficient to do this after 30 seconds to 2 minutes.
And was it your answer? Or you had something different?
No, not really, because I saw the photo, right? There's a brick sample, but I mean, what I'm asking is how long you need to soak the bricks in the river before you take out for a measurement? That's my question.
I think that this is a time that we need to put it as a sample inside the river, and
Yes,
then
correct.
that might Phytobenthos should grow up there, and then we can measure it.
Yeah, so
this is a
correct,
question that normally when you put this bricks inside the river, how long we should, 6 months, 4 months, 2 months?
How that depends. It depends. So it's clearly dependent on the nutrient situation that you have. Sometimes you see that it's growing very fast. In this experiment where we have so-called eutrophic situation, this experiment lasted 30 days. But I think you can measure after 1 week. Depends also on the substrate that you have. Of course, if it's rather coarse on the substrate, the biofilm can easily much more attach to the surface. If it's smooth, then it's very difficult. Many people like to use such tiles, ceramic tiles, which have a clear defined surface. And this picture which I showed with the ladies there, which put some tiles inside of a river, they use it for, let's say, 2 weeks and measured it. But of course, they put it again into the river and they come back after a certain while. So they want to continue. This is a big advantage that you can also see the dynamics of such a thing, which I mentioned also that that we have a situation. This is like a snapshot that you have, and you can come back and see how this is developing. And that is a big advantage of this measurement. You put the tile or the stone again to the same place and come back after a certain while and see, so that you have a time series of these measurements and get a complete record of the situation over a certain time.
I think it's also a sort of answer for Mr. Kundo, Dr. Kundo from Dubai, that there is a spot of measurement, and then you can see the time series of this data and how the evolution happening on this benthic algae grows in the sea or in the river or in the. I remember also in Danube River also there is some research on this type, but later we can discuss about this. So, Duan, you got your answer,
okay.
I guess.
Okay, thank you. Thanks. Thank you.
Okay, so I have also two more questions. Here is that there is how does turbid matters affect the measurement? Do turbidity also affect our measurement or not? Detlef?
Yeah, sorry, I did not get it.
The turbidity affect our measurement? The turbid matters inside the water.
Yeah.
Yes.
Of course. Yeah, turbidity. I think turbidity is an effect of turbidity is far exposed. The reason is why we are very close to the surface. That means the distance from the LEDs and the photo multiplier or the photo cells is so close that we do not have a turbid matter between the material. So you measure directly above the surface, and therefore in contrast to other measurements where we have an optical pathway, let's say in a spectrophotometer or in a spectropluorometer, it does not affect the measurement itself. So if you have high density, it may be something. If you have a layer of turbid matter that covers the layer of Phytobenthos, then of course it can make an effect. Yeah, but this is what I say. We measure, well, we try to measure the surface, and if we have only, let's say, turbid matter on the surface, you cannot measure everything. Yeah, that means what we know is if we have turbid matter on the surface, it means that the layers below them, they probably are not viable. That means that are dead materials. Yeah, so effect of turbid methods does not play a role with this Phytobenthos.
So other fluorometers. Okay, I got it. And the question is also about the price of the unit.
Yeah, yeah, yeah. That is a good question, of course. But you know the economical situation. You know this with the taxes, and you know what goes on in the world. Yeah, and you know US America and what's about their budgets and so on. I cannot give a clear answer. You can ask us to send to you, let's say, some information about this, but depends on the country where you live in. So you have to ask your local distributor, what is the local price? For example, in Brazil, they have 40% to the income taxes, yeah, and they import taxes, sorry, they have import taxes which are rather low. We do not know what US America will do in the near future with this import taxes. So it's not clearly to give a good answer. Ask your local distributor to get this information. Right? So then
as an email to us also, we can forward your question or request to our local distributor.
Yeah.
Also, it is possible.
Yeah, that is what we like to do. Otherwise, we cannot help you in this way. It really depends also on the local market. Yeah, and we are distributor for Germany, but we are not a distributor in these other countries. And of course, you distributors who are inside of this presentation, you take part in this presentation, you know about this effect and how to deal with. So please go to your distributor and ask them directly.
Okay. We are getting close to the end of our webinar. Just one, we have two questions. We have three, but I took one of them. Does the evaluation software cost, etc.?
Sorry, the
evaluation software. The
evaluation of software. Yeah.
Yes, it needs to pay more, or this is different.
The evaluation software, yes, I did not mention it. It comes, of course, with the BenthoTorch. It is something which you have to use with your computer, with your PC. So that is a program that is used with all our fluorometers that makes the calculation again and shows you the data in a table and enables also to do a recalculation. So that means that you have the advantage to have these all data in a table. When you use the BenthoTorch itself, it is also calculated, but you see only the result on the display. Yeah, and when you want to read it out, you use this evaluation software, and you get all this data also together with coordinates. That, for example, if you want to know at which place you are, it is also a big advantage that you do not need any record from the global information that you got for this place. It is the coordinates are automatically recorded together with the data, so that you can also add them later on a map, for example.
Okay, the last question. I hope that you can answer in 1 minute or 2 minutes. Thank you for a nice presentation. I wonder what the taxonomic detail is that can be achieved. Can we go more details than cyano brown algae? Maybe the question is that can we go to species type? I'm not sure, Mr. or Mrs. Hetty. If you want, you can ask your question yourself, or I read correctly or not. Can we go more than species? Yes.
Yeah, that was my question, if we could go to species level or if we stay on the free groups, free taxonomy group.
Yeah, species, yeah, they're far away from it, very far away, because I think you don't know if you characterize these algae classes, and I say only classes, it's not a very good taxonomic explanation for that. We know only the interference of the different pigments with this photosynthetic apparatus or with this light harvesting complexes. And you know that we have some of them which are really special. Then, for example, it's quite easy to see the interference of the phycocyanin or the phycoerythrin with this chlorophyll A in the photosystems, but it's not able to make it more detailed. And I think it is an optical method, yeah. And so far we are not able to go much more into the details. We can have much more information, let's say, for example, for different fucoxanthines. It's possible to do something like this, but from spectrofluorometric approaches, they are so similar that it's not easy to distinguish them. Therefore, we have the difficulty also with the dinoflagellates. Many of them, they have the peridyne inside of them, but we are not able to distinguish between the peridyne and the fucoxanthine at this moment. So therefore, I clearly can say, and I mentioned it also in my presentation, that I say is a very rough classification, and it's not able to go more into the details. And so far, I think the microscopic analysis is still the method to get more information about this, and will help you to go to the real information, what kind of algae you will have. For example, when I showed you the Microcoleus and the Formidium in the beginning, they are, for me, they with the instrument, they are the same, really the same. And of course, it is also limited insofar that we have differences of the additional or the accessory pigments. The accessory pigments, for example, or the amount of accessory pigments also depend on the nutrient situation. For example, if we have a high nitrogen content inside of the water, the amount of, let's say, phycocyanin could be higher than in other waters. And this, of course, influences also the signals. That means that we have circumstances where we cannot see a very clear determination of this class, but it is also, let's say, an estimation, and we cannot go closer into the information what kind of species, of what kind of genus we will have inside of this. Sorry for that, but optical ways does not give more information.
This was the answer that I was expecting, but still.
Yeah, but nevertheless, it is something which is on development, and we have another cooperation in Japan that try to make or to get more information about the relation of different wavelengths, yeah, that they can use. And we are also experimenting with the different wavelengths in our fluoroprobe, that we entered a new wavelength that also give more information. It will never, for my understanding, will never go into the details as you requested for such an instrument, but we try our best to get more information about this. And I think in the future we will have some much more information. We had this already, that we 20 years ago, but it is no one will pay for it. An instrument with 3 sensors, with 3 photo multipliers with different wavelengths for photosystem 2, for photosystem 1, and another one for the pigments phycocyanin and phycoerythrin. But this 3 sensor types and a lot of different light sources will be too expensive to provide it for the community, for the scientific community. So therefore, we are also a little bit limited in this case, but nevertheless, we hope that we could bring forward the, let's say, the way of optical, fluorometric optical analysis.
I think that we need to finalize. Do you have any further question? Okay, so I wish you a good day, good evening, and I think that we need to finalize it. It is from ours, it is 10 minutes to 12. It's 5 minutes late, but everything is okay, I guess. So thank you very much, everybody, and hope to see you next webinars. Yeah.
Thank you very much.
Take care of yourself. Bye-bye.